In this video, we're given some logarithms, and we're going to be asked to solve for these logarithms. And in order to do that, we're going to learn how to rewrite these, and so they look more like an exponential function. All right, so what I mean by that is here, if we have log base 3 of 27 equals what? It's asking, what does this thing equal? Well, we can't really figure this out now, unless you know a couple things which we'll get to in future videos. But what we could do instead is we could rewrite this as an exponential function. So this is my base, which is nice because it's also going to be the base of my exponent. And really, you take the base of your logarithm and you're going to say it's raised, I should say, to what your logarithm equals. In this case, since I don't know what that is, I'm going to call it x. All right, so I'm going to say 3 raised to the x equals, and it's going to equal the part that is saying log base 3 of. So in this case, it's going to be 27. All right, so now I have 3 raised to the x equals 27. How does that help me solve it? Well, if you remember that we can't really solve when something is up here in the exponent, but what we could do is make 27 also look like 3 raised to something else. What I mean by that is this is still going to be 3 raised to the x, but 27 could be written as 3 raised to what? Well, 3 to the first power is 3. 3 squared, what would that be? 3 squared is 9, so it needs to be bigger than 2. What about 3 to the third power? Yeah, that's 27. 3 times 3 times 3. And so I think 3 to the x is going to equal 3 to the third here. And now as long as these bases are both the same, my x is going to equal 3, right? Those are both in the same spot. So in order for my equal sign to be true, x would have to equal 3. All right, let's try another one. This time it says log base 4 of 16 equals what? So again, I'm going to replace this with x. And I'm going to say my base of 4 raised to that x equals this number, which is 16. This would be a little bit of an easier one, I think, because 4 raised to the x equals 4 raised to what is 16? Well, it's going to be 4 squared. So here, x is going to equal 2. All right, let's try some that are a little bit more complicated besides just x on the other side. All right, so like I said, these ones are going to be a little bit more complicated. And this first one here, it says log base 5 of 125 equals 6x minus 15. All right, so we still have to set this up kind of the same way as before, where my base is going to be 5. Remember, I raised it to the other side last time. So this is all going to be raised to the 6x minus 15. And that's going to equal that 125. All right, so my original part would still be the same. If this was just an x, it would still be like 5 to the x equals 125. And so I want to keep this as 5 because I think these can both be written as 5 raised to some power, 6x minus 15. And on the other side, 125 is 5 raised to what? Well, 5 squared is 25. 5 to the third, I think, is 125. So I'm going to make this a 3. And now you can essentially kind of cross out your bases, and you're just going to rewrite the exponents as a new algebra function. So I have 6x minus 15 equals 3. And if I add 15 to both sides, I can just solve this like an algebra 1 problem and get 6x equals 18. So x, if I divide both sides by 6, is going to be 3. All right, pretty simple there. Let's try another one. In fact, if you want to pause the screen and try it, you can. Here, my base is going to be 2, raised to the other side, x minus 6 equals, and then this is 64. So I want to make this 64 look like 2 raised to some power. And if you want, you can get out your fingers and count because we're going to go 2, 4, 8, 16, 32, 64. They got 6. So I think this could be 2 raised to the 6. So I'll say 2 raised to the x minus 6 equals 2 to the 6. And again, now our bases can cancel, leaving us with x minus 6 equals 6. If I add 6 to both sides, on this one, x is going to equal 12 in order for that equal sign to be true. All right, one last one here. Another 2. 2 raised to the x minus 11 equals 2. And you'll notice with this one, it's already a 2. All right, so how do I get an exponent up here? And all these other ones, I've had to change them. Well, with this one, if you think about your powers that you have available to you, this was like, what, 5 to the third, this was 2 to the sixth, but you can go lower. What about 2 to the, what's 2 to the 0? Well, that's 1. What about 2 to the first? Well, that's 2. Yeah, so because we want this to be 2, I think I have to put a 1 up there just by itself. Now I can cancel my 2's and get x minus 11 equals 1. Add 11, and we have another answer of 12. So x equals 12 for both these last two, and this one was x equals 3. All right, so hopefully that helps you as you can kind of rewrite these logarithms to help you solve when it comes to finding out what that x is in these. All right, until next time, keep doing your math homework fast and accurately.